Hello everyone, welcome back to our physics session. In this session, we are going to discuss worksheet questions based on magnetism and matter. Let us see what kind of questions we are going to face in the subsequent exams. An iron bar is having a cross-sectional area A is equal to cross-sectional area A is equal to 2 into 10 to the power of minus 5 meter square, and magnetizing field H is equal to 2400 ampere per meter. Produce a magnetic flux of 2.4 pi into 10 to the power of minus 5 Weber. WB stands for Weber. What will be the value of permeability, meow, and susceptibility, chi, of the bar, given that mu naught is equal to 4 pi into 10 to the power of minus 7 Henry per meter. Its unit is Henry per meter. Everything you need to learn. It's a learning stage. Yeah. He is asking mu and chi. H is given, and B naught will be all the possible formula we have to write so that you can select whatever you want. Will be better. B naught is equal to mu naught H. B naught is equal to mu naught H. B is equal to mu H, and chi is equal to mu chi. Mu r is equal to 1 plus chi is easy for you. 1 plus chi is equal to mu r. Mu r is equal to 1 plus chi. Is one more relation. Mu r is nothing but mu by mu naught, right? And anything else? Phi by A is equal to B. Phi by A is equal to B. So you have A, you have phi by A is equal to B, and mu naught H is equal to B naught. So once on getting that, you can have, that is mu naught into I plus H is equal to B. One more formula. So using all these things, one can attain whatever the required thing. Let us take another color for solving. B is equal to phi by A, 2.4 pi into 10 to the power of minus 5 by A is equal to 2 into 10 to the power of minus 5. This gets cancelled. This is 1.2 pi Tesla. And this formula applies. Mu is equal to B by H. B is 1.2 pi by H is 2400. So it implies this is like 12. 12 will go in 24 20 times because it is 1.2, that's why, and 2 zeros. So it is 1.2 pi 1 by 2 pi into 10 to the power of minus 3. So that is 5 pi into 10 to the power of minus 4. This is mu value. And mu r is equal to mu by mu naught, 5 pi into 10 to the power of minus 4 by 2 pi into 10 to the power of, 4 pi into 10 to the power of minus 7. So 5 by 4 is 0. 1.25 into 10 to the power of 3, that is mu r. So let us check up to whatever we have calculated. Mu value 5 pi into 10 to the power of minus 4. 5 pi into 10 to the power of minus 4. Here is there. These two. And susceptibility also they are asking. Okay, 1 plus chi is equal to mu minus 1. Mu r minus 1. That is mu r value, how much we got? Mu r is equal to 1250 minus 1. That means minus 1 implies chi value, right? So yeah, I will put up to mu r. then you can go for chi. Chi is equal to 1249. Yes, option C is coming as an answer. Yes, implies chi is equal to mu r minus 1. So that is equal to 1249. Wherever I got the place, I did. But okay, so it's a overall roundup of all the formulae. Good question it is. You need to have a good grip on all the things. See, first to the given related data, I wrote all the formulae on the paper. Then one by one, we substituted like that. Next, a thin magnetic needle is placed in a magnetic field 200 G. G is a CGS unit, Gauss. B is equal to 200 into 10 to the power of minus 4 Tesla. With its axis, theta is equal to 30 degrees in a direction to the field. Find the magnetic moment M of the needle if it experiences a torque is equal to 0.012 Newton meter in this field. 0.012 Newton meter in this field. Now torque tau is equal to mb sin theta. M is, we have to find, M is tau by b sin theta. Tau is equal to 0.012 by b is 200 into 10 to the power of minus 2 into sin theta, sin 30 1 by 2. So this 2 will go. So this 10 power minus 2 will become plus 2. So 1.2 will come. 1.2 ampere meter square is the moment. Option A. A planet has magnetic dipole moment of m is equal to 27 into 10 to the power of 22 ampere meter square. If the radius of the planet is 300 kilometer, noticed. What would be the magnetic field at its equator if mu is equal to mu naught by 4 pi into 10 to the power of minus 7. Equatorial field we are trying to find out. Then that is equal to mu naught by 4 pi into m by d cube. I can write m by d cube. So mu naught by 4 pi value 10 to the power of minus 7. M is 27 into 10 to the power of 22 by d cube is 300 into 10 to the power of 3 cube. Kilometers is converted. So it's a simplification you can take up 10 to the power of 22, right? So it should come 1. Let me check LCM in a little way. 3 cube is 3 3s are 9 3s are 27, 27 will go. All powers only will be left out. 3 3s are 9 and this is actually 5. 5 3s are 15. 15 and 7, 21. Yes, correct. Next. Susceptibility of A is something is missing, we'll see. Susceptibility chi is equal to 2 into 10 to the power of minus 5. The percentage increase in the magnetic field when the space within the current carrying toroid is filled with maybe a material, a liquid or something. Susceptibility is this one, percentage increase in magnetic field if the space between this so and so is filled with, usually initially B is there, B naught is there, finally B is there. So percentage increase means B minus B naught by B naught into 100. B is mu into H minus this is mu naught into H by this is mu naught into H into 100. So that is equal to H gets cancelled. Mu naught can be taken common. Mu r minus 1 by 1, I cancelled mu naught into 100. So that is equal to mu r minus 1. Now susceptibility chi plus 1 is equal to mu r. That means mu r minus 1 is chi only. So chi into 100 only, percentage change in B. So chi into 100, 2 into 10 to the power of minus 5 into 100. What a wonderful question it is. 2 into 10 to the power of minus 3. Okay. Yeah. Here I think you need one more step. I can. H gets cancelled, that everybody easily understood. So mu naught if I take common, this is mu by mu naught minus 1 whole by mu naught. into 100. Yeah. Let m and r be the dipole moment and radius of Earth respectively. M and r be the dipole moment and radius of the Earth respectively. Then the Earth's magnetic field at the equator is m and r be the moment, dipole moment. Okay. M is m. Radius of the Earth is r. He gave like that. And then the Earth's magnetic field at the equator. B at the equator is nothing but, suppose Earth is having, imagine like a magnet is present inside, at equator it is nothing but equatorial field. Equatorial field is equal to mu naught by 4 pi into m by d cube. This is formula. M by d cube is formula. So as per this sign convention, mu naught by 4 pi into m by that r cube, because distance is r. So option. So the length L length L of a magnet is large compared to its width and breadth. The time period of oscillation in the vibration magnetometer is T is equal to 2 seconds. The magnet is cut into 3 equal parts along parts of length L by 3 each. It is cut along this way. If these parts are placed on each other with their like poles together, then the time period of the combination. Actually, we have a shortcut. I'll explain lightly what happens to the procedure. Length become L by 3. Okay. Moment become M by 3. Moment become M by 3. Moment of inertia becomes cube. Moment of inertia becomes I by n cube. That means 3 cube, 27 it will be. Okay, put these two things in the mind. Then time period T dash is equal to 2 pi root I dash I by 27 m dash m by 3 into BH, whatever. So 3 will go 9 times, so it will come as T by 3. So T dash is equal to T by 3. If you make 3 pieces, then it will become T by 3. One piece moment, one piece time period T by 3. If they are placed one over the other like this, then what happens? You know, as you place it like this, okay, moment of inertia will be 3I. If it is I, moment of inertia will be 3I. And moment is m dash is equal to 3m. So in the formula, T is equal to square root of I by mbh with a quotient of 2 pi. Suppose I becomes 3 times, m becomes 3 times. So there is no change. So one piece moment, one piece time period and the 3 pieces time period will be same. That's what I want to say. One piece time period, 3 pieces time period will be same. I want to say both are same. So that is T by 3 only. T by 3 means 2 by 3 here. Yes. Next. At a location, the horizontal component of Earth's magnetic field is 0.3 G. At a location, Earth's horizontal field, BH, is equal to 0.3. G means Gauss, 10 to the power of minus 4, Tesla. And in the magnetic meridian and the dip angle delta is equal to 60 degrees. The Earth's magnetic field at this location in G is equal to B is equal to how much? So BH is equal to B cos del is the formula. So BH value is given 0.3 into 10 to the power of minus 4. In G only they are asking. So in G only will come. That is equal to B. I have to cos 60 1 by 2. So 0.6 G is the answer. 0.6 G. Two small magnets have their masses and lengths are in the ratio two small masses and lengths in the ratio m1 by m2 is equal to L1 by L2 is equal to 1 by 2. The maximum torque experienced by them in a uniform magnetic field are same. The maximum torque experienced by them in a uniform magnetic field are same, T1 equal to tau 2. For small oscillations, the ratio of their time periods is the ratio of their time periods is okay, ratio T1 by T2 equal to how much? What we have, time period formula T equal to 2 pi root I by MBH. This is the formula. Torques are equal. So what kind of relation we can establish with torques? Torques is equal to MB sin theta. MB sin theta. In a uniform magnetic field are same. Maximum torques, that is M1 B1, M1 BH1 is equal to M2 BH2. That means M2 BH2. That means this factor will be same for the both magnets. That is his intention, because maximum torque is MBH only. Whatever. I's you can compare. I1 by I2. I1 by I2 equal to I is ML square by 12. So ML square by 12. This is 1 1. This is 2 2. Here M1 by M2 is 1 by 2. L1 by L2 1 by 2, and it's a square. So I1 by I2 1 by 8. I1 by I2 1 by 8. So T1 by T2 is equal to root over I1 by I2. Root over I1 by I2. So that means root over I1 by I2, 1 by 8 only, no? So 1 by 2 root 2 will be 1 by 2 root 2 is there, root 2 root 2 is there. Whenever this type of options you face, you should be very careful. Okay, 1 by 2 root 2 we got. Next, a bar magnet of length L is equal to 16 centimeter is placed in the magnetic meridian with north pole pointing towards geographic north. North pole pointing towards geographic north. Two neutral points separated by 12 centimeters are obtained on the equatorial line, okay, of the magnet. The horizontal component of earth magnetic field BH is equal to 3.2 into 10 to the power of minus 5. Whenever two neutral points are obtained on the equatorial line at a distance of 12 centimeters, that means one to one neutral point distance is 6 centimeters. That only we have to take. D is equal to 6 centimeter. This is 6 centimeter, length of the magnet 16 centimeters. So it's not negligible, comparable length, that we have to put in our mind. And then the pole strength of the magnet M is equal to question mark. Actually at null point BH is equal to B produced by the magnet. BH is, okay, we know B is equal to mu naught by 4 pi into, this is equatorial, so M by D square plus L square whole power 3 by 2. Basic formula you have to take, not the shortcut one. You shouldn't take DQ. Okay, so here after finding M, we can go for 2LM. M is equal to 2LM. M equal to 2L into M. So this M we have to find out. So for that, I will write here you can replace with the 2L into M. Then M can be subjected. I want to subject like this. M is equal to BH into 4 pi by mu naught into D square plus L square whole to the power of 3 by 2 by 2L. So substitute all the given data. It's in centimeter. You have to write in 10 to the power of minus 2, and you have to write in 10 to the power of minus 2. Then that substitution also I'll write, so that you can feel somewhat comfortable. Yeah, BH is 3.2 into 10 to the power of minus 5, 4 pi by mu naught, 4 pi only here. Here mu naught value 4 pi into 10 to the power of minus 7 into D square D square 6 into 10 to the power of minus 2 D square plus L square, L equal to a bar magnet of length 16 centimeter. That means 8 only you have to write. This is actually, he gave like this, but it should be treated as 2L. It should be treated as 2L. So L is 8 into 10 to the power of minus 2, and it's a square, L square, and it's 3 by 2, power 3 by 2 by 2L. 2L is 16 only, 16 into 10 to the power of minus 2. Now I simplified this and I got 2 ampere meter. Yay. You to do. Next, a short bar magnet placed with its axis 45 degrees with the uniform external field, and that field B is equal to 28.3. Whenever Tesla you noticed, you write B. If you notice ampere per meter, you write H. experience a torque tau is equal to 3.6 into 10 to the power of minus 5. The magnitude torque, Newton meter I have to write, not joule. And the magnitude of magnetic moment of the magnet experienced by M is equal to how much? You know, tau is equal to mb sin theta is our formula. So M is equal to tau by b sin theta, just substitution. Tau value, why should I waste time? You got it. Next. Two electrons E1 and E2, mass M, charge Q, are injected into perpendicular direction into the magnetic field B such that kinetic energy of E1 is double to that of E2. Kinetic energy 1 is double to that of E2. The relation between their frequencies of rotation F1 and F2 is the relation of their frequencies of rotation F1 and F2 is the relation of their frequencies F1 and F2 equal to how much? Frequency. Okay. See, you have 2 pi m by bq relation is there, that only. I want to derive once again for your convenience. You know R is equal to mv by bq very well. Whenever a charge is projected into a magnetic field, right? This you know very well. Now, keep on watching. V by R is equal to omega. That is equal to V by R is equal to bq by m. In this, frequency will come automatically. Omega means 2 pi f. So frequency f is equal to bq by 2 pi m. 2 pi m. So this relation he is asking. B is same for the both. 2 electrons, q is same for the both. Mass same for the both. So obviously it is independent of kinetic energy. So frequency f1 and equal to f2. So both are going to have 1:1 relation. Next. A bar magnet having magnetic moment. At this stage, you shouldn't feel that, sir, this question belongs to that chapter, that question belongs to this chapter. Not like that. Whatever the question comes, you need to practice. A bar magnet having a magnetic moment M is equal to 2 into 10 to the power of 5 units, ampere meter square. Now is placed along the direction of uniform magnetic field of B is equal to 14 into 10 to the power of minus 5 Tesla. Work done in rotating a magnet slowly through 60 degrees. Here, theta 1 is in the same direction, theta 2 is 60 degrees. Now, with work done he is asking, that is mb into 1 minus cos theta. mb 2 into 10 to the power of 5, 14 into 10 to the power of minus 5 into 1 minus 1 by 2. So this is 1 by 2, 2 will go. So for 10 power 4 will go. So answer is this one. Next, so it will be 0.025 and into 10 to the power of minus 3. So 0.025 millijoule. A magnet of magnetic moment M is rotated through 360 degrees, theta equal to 360 degrees. In a magnetic field H, the work done will be 0 because in one complete rotation, in one half rotation, its potential energy increases. Again, in the another half rotation, it decreases. So 0. A proton and an alpha particle are simultaneously projected in opposite direction into a region of magnetic field of 2 millitesla. Magnetic field B is equal to 2 millitesla, perpendicular to the direction of the field. After some time, it is found that the velocity of proton has changed in a direction 90 degrees. Then, at this time, the angle between the velocity vector of proton and alpha particle is, good question, 2 millitesla. What will, one is proton, one is alpha particle, right? Proton mass is 1 unit, charge is 1 unit. Here it is charge 2 units, mass 4 units. So here time period story. So time period T equal to 2 pi m by bq. 2 pi m by bq. So B is same. M by Q's are different. M by Q's are different. So time period of proton by time period of alpha particle is M of proton by M of alpha into Q of alpha by Q of proton. So M of proton, M of proton, M of alpha. M of proton, M of alpha. 1 by 2, no, 4 into Q of alpha 2, Q of proton 1. So it will be 1 by 2 ratio. That means one's time period is 1, other one time period is 2. Suppose proton has taken 90 degrees, then it will be only half of that only. That means it will complete only 45 degrees. So one has completed 90 degrees, proton has taken 90 degrees, and then alpha particle will complete only 45 degrees because its time period is very less. So angle between them is automatically 45. Difference only, no? Right. Yeah. Next. Susceptibility of a paramagnetic material is susceptibility. Chi is equal to 99. Permeability of the material is dash. Permeability is yes. If you have 1 plus chi is equal to mu r, that means 100 is equal to mu r, that is equal to mu by mu naught. So mu is equal to mu naught into 100. Mu naught is 4 pi into 10 to the power of minus 7 into 100. So that is 4 pi into 10 to the power of minus 5. 4 pi into 10 to the power of minus 5. Magnetic material area 0.25 centimeter square. Cross section area is placed in a magnetic field. Strength H is equal to 1000 ampere per meter. Then the magnetic flux produced is equal to how much? Area is given, H is given, phi is given, and susceptibility of the materials chi equal to 313, and free space mu naught value is given. Okay. Chi is chi, okay, then mu r is equal to 1 plus chi. That means this will become 314. This is equal to mu by mu naught. So mu is equal to 314 into mu naught value 4 pi into 10 to the power of minus 7, that is equal to nothing, because 314 is nothing but 10 pi, that's it. Not 10 pi, 100 pi, 3.14. But okay, I'll leave here, it is like this only, later we'll think about it. Area H phi chi, okay. Mu we got, mu into H will be B. B equal to phi by A. So what we want? Phi, okay. Phi is equal to BA, that is equal to mu HA, that is equal to 314 into 4 pi into 10 to the power of minus 7 into H value 10 power 3 into A value 0.25 into 10 to the power of minus 4, and its simplified value is A 9.87 into 10 to the power of minus 6 Weber. Next, Curie temperature of cobalt, Curie is 1400 Kelvin. Cobalt and iron is equal to 1000 Kelvin. Iron you need to mention like Fe, that will be better. And at T equal to 1600, the ratio of magnetic susceptibility of cobalt to that of iron is, okay, Curie temperatures are given. Okay. We have Curie's law, that is equal to susceptibility is equal to some constant B by T minus Tc. So from this, chi of cobalt by chi of iron is equal to T minus Tc by T minus Tc of so-called, this is Fe and this is cobalt. So that is equal to T minus Tc, T value 1600 minus 4 Fe 1000 by 1600 minus 1400. Next, this is 600, this is 200. So it will be 3, right? Okay, B option, yes. Next, Earth's magnetic field always has a horizontal component except at, always has horizontal component except at poles. At poles, no horizontal component. Poles means magnetic poles. Yes. See, at magnetic poles, magnets, if you suspend, then it stands vertical, then automatically it will have only vertical component, no horizontal component. At equator, it will have only horizontal component, you are right. The ratio of magnetic field at the center of current carrying circular coil has its magnetic moment is X. ratio of magnetic field at its center of a current carrying circular coil moment is x. Come again, ratio of magnetic field at the center of current carrying coil to its magnetic moment is x. If the current and the radius both are doubled, current I dash is doubled and radius r dash is doubled, the new ratio will be okay. First of all, b naught is equal to mu naught I by 2r. This is for a circular current carrying coil. It should be converted in terms of m. M is equal to INA, right? M equal to INA. N is number of terms. M is equal to INA. IA I can write. IA. So mu naught by 2r into I can be replaced. I is also there in the formula. So what I can replace? I have to write like this. I into pi r square. So r can be replaced. R also changed. So M here is independent looking. I is there, R is there. V by M ratio. Okay, we will do in a different way. Wait. Zoo. We will create M V naught by M ratio only. V naught by M. M is equal to IA. Okay. Now B naught by M is equal to mu naught I by 2R into IA. A is pi r square. Now II gets cancelled. Mu naught, I want only proportional to 1 by r cube. So it is just ratio 1. Suppose ratio 1 by ratio 2. Ratio 1 by ratio 2 is equal to r2 cube by r1 cube. R2 by R1 is 2. Its cube is 8. That means it will be R2 is equal to ratio 2 is equal to R1 by 8. Yeah, so that is x by 8 it will be. Coercivity of a magnet where the ferromagnet gets completely demagnetized is coercivity C is equal to 3 into 10 to the power of 3. And the minimum current required to be passed in a solenoid to having N is equal to 1000 turns per meter, okay, per meter, so that the magnet is completely demagnetized when placed inside the solenoid. Coercivity units are ampere per meter. Ampere per meter means it's identical to H. So H reverse needed is equal to mu naught Ni. B is equal to mu naught Ni is the solenoid's magnetic field. So B by mu naught is Ni. That is H. H is equal to Ni, just Ni. So I is equal to C by N. C value 3 into 10 power 3. N value 10 power 3. So answer is 3. So 3 amperes. Such a high current it is. Ampere is a large current. The strength of Earth's magnetic field is constant everywhere, wrong. Zero everywhere, wrong. Having very high value, varying from place to place on the Earth's surface. D. Which of the following properties are false for a bar magnet? It doesn't produce magnetic field. Its poles cannot be separated, which is wrong. False statement. It points in north-south direction when suspended. Its like poles repel and unlike poles attract. D corrective. Suspended, C corrective. Poles cannot be separated, corrective. So option A wrong. Susceptibility of a ferromagnetic substance is susceptibility of ferro very greater than 1. Next, X1 and X2 are susceptibilities of magnetic materials at T1 and T2 respectively. Then from suppose it is a paramagnetic susceptibility is inversely proportional to T. That means Xt is chi T is constant. So chi 1 T1 equal to chi 2 T2. Option B. And there is no torsion in the suspension thread. Then the time period of magnet executing SHM is there is no torsion. Then T equal to T equal to 2 pi root I by mb. T equal to 2 pi root I by mb is D option. The free space inside the current solenoid toroid is filled with a material of susceptibility this. The percentage increase in the value of magnetic field inside. Percentage increase in magnetic field is equal to chi into 100. So chi value is 2 into 10 to the power of minus 2 into 100, 10 power 2. So answer is 2%. The angle of dip at a place del is equal to 37 degrees vertical, and the vertical component of Earth's magnetic field BV is equal to B sin del is equal to 6 into 10 to the power of minus 5. Then the Earth's magnetic field at that place is equal to B equal to how much? So B is equal to 6 into 10 to the power of minus 5 by sin del, sin 37 degrees. Sin 37 degrees is 3 by 5. 3 by 5. 6 by 3 by 5 into 10 to the power of minus 5. So 3 will go 2 times, 10. 10 to the power of minus 4 it will be in a respective unit. Variation of magnetic susceptibility with temperature for a diamagnetic. Diamagnetic, it won't respond and it is negative. So negative side you need to take up. See, actually, if you observe carefully, this is totally a wrong graph because he gave in the positive side. Actually, negative side is correct. This is correct graph. And this is correct for paramagnetic. This is correct for ferromagnetic. So option B is correct for this. Free space inside a current carrying toroid is filled with a material of susceptibility this and the percentage increase. Same repeated question I think. This is B is equal to percentage change in B is equal to chi into 100. So chi value is 2 into 10 power minus 2 and to 100 10 power 2. So this will be 2%. Okay. So end of this session. We'll discuss another chapter questions in the next session. Keep on practicing. Be focused. Push yourself.